Let's go through another example. Question 4. Water is flowing in a vertical tapering pipe 2 metres in length. The top of the pipe is 100 millimetres diameter and the bottom is 50 millimetres diameter. The quantity of water flowing is 1300 litres a minute. Calculate the pressure difference between the top and the bottom of the pipe. That's the question. Remember, what's the first thing you do every time? Produce a sketch. Look at this sketch here. This is identifying the problem. At point A, point B. Now, you've got 2 metres high, 100 mil diameter and 50 mil diameter. Where are you going to take your datum? Your datum has got to be level with B. At the bottom, point B. So point A is at the top, point B is at the bottom, and that's your datum line. Your datum line is level with point B. Then you've got to convert all to SI units. What's the SI unit for flow? Q? Metres cubed a second. Now in this case it says it's 1300 litres a minute. Do you understand straight away? 1300 litres a minute, you've got to convert that into metres cubed a second. So by converting it you have to times it by 60 to give it a second and divide it by 1000 to give it metres cubed. And that gives you a Q of 0.0217. Now we can determine the velocity at both point A and B. Now we know this because we're going to work out the area and we know the quantity of water. First we need to determine the area at points A and B in metres squared. So the area at point A, using the familiar formula 0.7854 times d squared, gives you 0.7854 times 0.1 times 0.1 equals 0.007854. And the area at point B, same formula, 0.7854 times d squared is 0.7854 times 0.05 times 0.05 equals 0.001963. That's the area. Then, using continuity, VA equals Q divided by AA. The velocity at A is 0.0217 divided by 0.008784 gives you 2.7 metres a second, and the velocity at B comes out using the same numbers as 11.07. So you've got the velocity at A and you've got the velocity at B. So now you can work out the velocity energy at A and the velocity energy at B. Now we can insert all known values in the formula, which in this case, because it's just asking for pressure difference, we choose the formula with pascals, because in here, because it's not asking you any particular formula, so you can just choose any formula like, because it's in pascals, the pressure energy. So we'll choose the formula in pascals. Don't forget, it's asking the pressure difference, so that's why we're using pascals. And the formula for pascals is this formula here. And don't forget, it's just the PA, and on the other side, PB. This is a formula Bernoulli's when it's just pascals. Then you substitute in all known values. Giving you this, PA, the pressure energy at A, plus 1000 times 981 times 2, plus a half times 1000 times, don't forget the velocity energy is 2.76 squared, equals PB plus 0, don't forget at point B there's no potential energy, plus a half times the density, which is 1000, times, now we put in 11.07, which is the velocity at B, squared. Do you understand? All you do is you substitute in all the values that you know into that equation, and you cancel out what you can. If you multiply this all out, looking at this here, you multiply it all out, you get this. PA, the pressure at A, plus 23,428.8 equals PB plus 61,272.45. Transpose by taking away the smallest value, which is 23,428 from both sides, gives you PA equals PB plus 37,843.65. Again, transposing, take away PB from both, it gives you PA, the pressure at A, minus the pressure at B equals 37,843.65. What's the pressure difference? Well, that is the pressure difference. The pressure difference between PA and PB equals 37,843 pascals. That is how you do this question. That was an easier question to apply than the other ones. But that is how you do the question. Don't forget the method. Don't forget the method.